Hello everyone. Once again, I'm Engineer Raymond Jan Evangelista. Alright, so in this video, we will talk about on how to find the logarithm of a complex number and followed by evaluating an expression containing a complex number raised to another complex number. Okay, so let's start with the topic logarithm of a complex number. Okay. By the way, in this topic, we will um, result no, into two special cases. Okay. So, what are those? Of course, when we are talking logarithm, we have two common bases. Okay, that are being used now. So those are logarithms with base of 10, or called the Briggshian or common logarithm. Okay, and the other one logarithms with base e, the natural number. Okay, so those are called natural logarithm or natural log. All right, but before we proceed to these cases, let us generalize on how to find the logarithm of a complex number. Okay, now in getting the logarithm, no, we have to use the more proper form of a complex number. Okay, recall that we have a different forms of complex number. Now we have the rectangular form na yung ating x plus jy. We have the trigonometric form na r cos theta plus j sin theta. We have the polar form r cis of theta. We have the exponential form. Okay, so r e raised to j theta. Okay, so in getting the logarithm of a complex number, the suited form, okay, is the exponential form. Okay, because when we get the log, okay, of this expression, take note, this is a product of r and e raised to j theta. Okay, so we can apply the properties of logarithm. Okay. So remember, our complex number is denoted by z. So we have here um, r e raised to j theta. Okay, let's say we have a number, okay, a base of e, okay, not equal to 1, okay, and is positive, okay. Now, so let's take the logarithm of both sides now with base a. Okay, so log of j to the base a is equal to the log of r e raised to j theta, okay, to the base a. Okay, recall the property of logarithm na if we have product of log of ab, okay, if we have product here, okay, that will become sum. Log of a plus the log of b. Okay, so you can consider our a here is r and our b is e raised to j theta. Okay, so we can write this expression into log of r to the base a and then plus log of e raised to j theta to the base a. Okay. Again, we can use another property of logarithm. So if we have power inside the logarithm, so let's say log of a to the base a, okay, raised to m. Okay, so you can put the exponent now outside. So that is m log of a to the base a. Okay, so it is just writing j theta now beside the log. Okay, so this will become the log of z to the base a is equal to the log of r to the base a plus the log of wait, the log of e to the base a and then j theta. Okay, take note guys, now always remember that our theta here now is in radian units. Ah, okay, don't forget that. So this our general form for the logarithm of a complex number. Okay. Now we can go to the first case. Now, for case one, okay, when the base is 10. So um, logarithm with base 10 are called common or Brichan logarithm. Okay. So when the base is 10, you don't have to write the base 10. Okay. So let's say log j to the base 10. So you can write that as log of j only now. So understood, if it is not written, the base is 10. Okay. So if a is 10, okay, this expression will become log of r plus log, okay, wait, log of e, okay, and then j theta. Okay. You can calculate the value of this. Okay. So you can find out that it is equal to 0.434. Okay. So also equal to log of r. By the way, I will not require you to memorize this one, so that you know how to get the log of complex number na from time to time na. Okay? Ayan. So log of r plus um j theta, and then 0.434. Okay? How about the next case? So when the base is e. So case 2, okay, when a is, okay. By the way, no. So again, logarithms with base e are called natural logarithm. Okay. So the log of j to the base e. Okay, when the base is e, you can write log to the base e as ln. Right. So it is also read as ln, okay, natural log. So ln of j is equal to ln of r plus j theta, and then the ln of e. Okay. Take note this part. Okay, this one. Okay. That is the same as log of e to the base e. So when the expression inside the log is the same as the base, now this is equal to 1. Okay. So when the base is e, the logarithm of complex number is much simpler. All right. So the log of j, or the natural log of j, okay, natural log of j is equal to the natural log of r plus j theta. Okay. So remember those method na on how to get the logarithm of a complex number. Right. So next we will solve sample problems na on how to get the natural log, the logarithm, I mean, of some complex numbers. Alright, so let's try to solve these sample problems. Right. So number one is the logarithm of quantity 1 plus j. Number two is the logarithm of natural log of 2 c's of 30 degrees, and number 3 is the log of negative 3 plus j4 to the base j. Okay, so we have different cases here now. The first one is the common base. Second, sample problem, so base e, and the third sample problem, so with the base of complex number. Okay, so we will use another property of log, okay, to evaluate this one. But the main concept here is the of course the logarithm of the complex number now. We will just use some property to make it more simpler, right? So number one, the log of 1 plus j. Okay, so always remember now, before you get the logarithm of the complex number, so make sure that it is expressed or written in complex form. So we have to write 1 plus j in exponential form. Okay. our r here is equal to understood na our x and y are both 1. So our r here is 1 squared plus 1 squared. So that is the square root of 2. And for the angle, so theta here is the arctangent of our y is 1, also x1. So arctan of 1 is actually na 45 degrees. Okay? Then you should convert this to radian. So this equivalent to pi over 4. If you don't know the equivalent, so use the conversion. Okay? So just multiply this by pi over 180 degrees. Okay? That will give you pi over 4. Okay? So therefore, 1 plus j is the same as the square root of 2 e raised to j and then pi over 4. Okay? So, we know that the log of z, okay, is equal to the log of r plus j theta and then the multiplier 0.434. Okay, so substitute the values for r and theta, we will get a log of the square root of 2, okay, plus j and then pi over 4 multiplied by 0.434. Okay, so let us simplify or evaluate the terms here na into its decimal form. Okay, log of square root of 2 is 0.15. Let's say 4 decimal places, so 0.1505, 0.1505. Okay, and then plus, okay, pi over 4 multiplied by 0.434. Okay, pi over 4 times 0.434. Okay, that is 0.3409. Okay, so this is the equivalent expression for the logarithm of 1 plus j. Alright, so the next problem is the natural log of 2 cs of 30 degrees. Okay, natural log of 2 cs of 30 degrees. So as you notice, the given complex number na inside the natural log is already in polar form. Okay, so you just need to convert 30 degrees into radian. All right, so this is our theta. 30 degrees multiplied by pi over 180 degrees. Okay, that will give you an angle of 30 over 180 is 1 over 6, so that is pi over 6, right? And this is our r. Okay, so therefore the complex number 2 cs of 30 degrees is the same as 2 e raised to j pi over 6. So the natural log of 2 cs of 30 degrees is the same as the natural log of 2 e raised to j pi over 6. And remember, okay, the natural log of of r e raised to j theta is simply the natural log of r plus j theta. So you just copy everything now. Alright, so we have the natural log of 2 plus j and then the angle which is pi over 6. Actually, this is already acceptable answer. Okay. Otherwise, unless otherwise there are choices na you have to convert or write this in decimal form. Okay, but for our formality of solution, so this already accepted na. Okay, then the last one, so the log of negative 3 plus j4 and then to the base j. Okay? Okay, log of negative 3 plus j4, okay, to the base j. Okay? So, we have to write this first now. Okay? Remember, we only have two cases na base 10 and then base 8. Okay? So, we will make use of those method na. Okay? So, here, I will choose the second case, which is the natural log na. Okay? So, because as you can see na, the natural log of complex number is much simpler na to write. Okay, it only involves the natural log of the r and then plus j the angle. Okay, so that means na, okay, if you want to write this expression, you will use base e. Okay, in logarithm we have the so-called the change of base. So say for example, change of base. So say for example, we have here log of b to the base a, and we want to introduce another base, let's say c. Okay, so this can be written as the log of b to the base c over the log of a to the base c. Okay, so this one, if we introduce the new base e, so this can be written as the log of negative 3 plus j4 to the base e. Okay, and then the log of j to the base e. Okay, remember, if the base is e, you don't have to write a log of e na. Instead, write ln. Right, so ln of negative 3 plus j4 over the natural log of j. Okay, so the next step here is to convert the complex numbers na negative 3 plus j4 and j into its equivalent exponential form. Okay, let's start with negative 3 plus j4. Okay, our x is 3, negative 3, and our y is 4. Okay, so our r here is equal to the square root of negative 3 squared plus 4 squared. Okay, so that is 9 plus 16, the square root of 25, so that is 5. Okay, and for the angle, so we have theta, the arctan of what? Of 4 over negative 3. Okay, then guys, our x is negative and our y is positive. So in what quadrant will angle lies na? Negative positive, that is in a second quadrant. So okay, make sure that your angle is between what? Okay, from here to here na, that is between 90 and 180 degrees. Okay, because if you get the arctan of 4 over negative 3, so let's try 4 divided negative 3. Okay, it will give you an angle of negative 53.13. So that is in the fourth quadrant. Okay, so if this is 53.13, this also 53.13 degrees. So the required angle is here now. So that is 180 minus this angle. Okay, so again we will get here we will get negative 53.13 degrees. So to make sure that theta is in quadrant 2, okay, we will add 180 degrees. Okay, so our angle here is what? So plus 180, okay, we will get 126.87 degrees. Okay, and then this angle should be converted into radians, so multiply by pi over 180 degrees. Okay, so it will give you an angle of times pi over 180. Okay, so that is 2143. Okay? 2143. Yan, radian. Okay? So, therefore, negative 3, okay, negative 3 plus J4 is the same as um, our R is 5, 5 e raised to J 2.2143. Okay? So that means the natural log of negative 3 plus J4 is the same as the our R is 5 now. So ln of 5 plus our theta is 2.2143. So J 2.2143. Okay? Next one is the natural log of J. Okay? So how do we write J into its equivalent exponential form? Okay? Understood the R here is 1. Okay? If it is not written out. And then J, that means our complex number or our point is in the positive y-axis. So this gives us an angle of 90 degrees. So J is the same as um, um, 1/6 of 90 degrees. Okay? Or what is 90 degrees in radian? That is pi over 4. Okay? So therefore, J is the same as 1. Okay? Or you don't have to write 1. E raised to J. I mean pi over 2. Sorry. Pi over 2. Pi over. Okay? So therefore, the natural log for J is the same as the natural log of 1 e raised to J pi over 2. Okay? Our R is 1. So ln of 1 plus J pi over 2. Okay? The natural log of 1 or the logarithm of 1 is obviously 0. Okay? So this simplifies to just J pi over 2. Okay? Therefore, the log of negative 3 plus J4 to the base J, which is the same as the natural log of negative 3 plus J4 over the natural log of J, okay, which is also the same as the ln of 5 plus J 2.2143 over pi over 2 J. Okay? Then let's use calculator now to simplify this one. So we have here ln of 5 plus 2.2143 I, then pi over 2 or pi I by 2. Okay? So that is 1.4097. Okay? Minus 1.0246 minus J 1.0246. So this is the equivalent value or expression for the log of negative 3 plus J4 to the base J. Alright? So that's it for this topic. Logarithm of complex number. Alright, so our next topic is on how to evaluate expression containing complex number raised to another complex number. So from the word itself, halimbawa, we have a complex number, let's say 3 plus J4. Okay, and then we raise to another complex number, let's say 1 plus J. Okay, so we will discuss now one by one on how to evaluate this kind of expression. Okay, so let's start by letting this full expression as y. Okay, now the the expression or the term that makes this problem na, or expression difficult is the exponent na 1 plus j. So our first aim is to remove 1 plus j, the exponential complex expression. No? Okay, in this part. No? Okay, so how do we remove that? Okay, or how do we um, change the position of this? No? Okay, I remember that in our logarithm. No? Okay, if you have um, let's say a raised to n, and then you take the log of that, okay, what will happen? Okay, the exponent now, okay, will become the coefficient of the log. No? So that is the same as n log of a. Okay, so let's start by taking the log or the natural log now. Okay, I prefer the natural log now kasi nga the natural log of complex number is much simpler than the common log of complex number. So let's take the ln of both sides. Okay? ln of y and then the ln of fraction of 3 plus j4, then 1 plus j. Okay? So this now, we are sure that we can write it here now. Okay? So this is the same as quantity 1 plus j and then the natural log of 3 plus j4. Okay? So we have to evaluate the natural log of 3 plus j4. So let's do it here now. Okay? Right. So ln of 3 plus j4. Okay? Convert 3 plus j4 into exponential form. So our here is the square root of 3 squared plus 4 squared. So that is obviously equal to 5. Our angle is the arctan of 4 over 3. Okay? And make sure that the resulting angle is in radian now. So if you I will show you now on how to directly get the angle in radian now. Okay? By the way now, make sure that when you are solving what do you call this? Complex number raised to another complex number. Okay, make sure that you are using the suited angle now. Okay, or the the angle mode now. Okay, so when to use radian and when to use degrees now. But if you master the solving of this kind of problem, no? So you didn't have to be worried of the angle mode now. Okay, whether it is in angle degree or in radian now. Okay, but in this method I will show you now. Okay, when and where to use radian and degree now. So say for example when you get the arctan of 4 over 3. Okay, so take note our mode here is degree, so obviously the angle is in degrees now. So if I change the mode into radian, okay, it will give you the angle in radian. Okay, so that's how you do it now. So this is 0.9273 radian. Okay, so therefore the natural log of 3 plus j4 is the same as the ln of 5 plus j 0 point angle 9273. Okay, now we have here the quantity 1 plus j multiplied by the equivalent of ln 3 plus j4, which is ln of 5 and then plus j 0.92 73. Okay, so okay, in this topic guys I will allow you to use calculator in this part. Okay, so just type this in your calculator. Okay, that is 1 plus then quantity ln of 5 plus 0.92 0.73. Okay. Then post parenthesis. So we have here 0.6821 uh, plus 2.5367, right? So plus j 2.5367. Okay, the next one is to change the logarithm into exponential. How do we change logarithm to exponential now? If we have here the ln of y is equal to x, and this is the same as what? Y is equal to e raised to x. Okay, okay. So this one. So y here will become e raised to 0.6821, okay, plus j 2.537. Okay. Okay, so take note of the every steps ha. Okay. We let the given expression to y. We remove the exponent. Okay. We take the natural log of the base 3 plus j4, and then we simplify. Okay, and then what? We revert the um, equation into its equivalent exponential now. Okay? Now the next step, guys, is to separate the exponent. So take note, we have here addition ng exponent. Now whether it is plus minus, so just separate, guys, now. Okay. Um, um, say for example, if you have e raised to m plus n, that is the same as e raised to m and then e raised to n. Okay. If you have e raised to m minus minus n, that is the same as e raised to m e raised to negative n. Alright, so whether it is plus minus, you just separate now, and then you include the sign to the other expression, like this one. So this one can be written as, okay, um, um, e raised to 0.6821, and then e raised to j 0. That is 2.5367. Okay. So observe the terms here now. Okay. So when you separate the terms in the exponent now, okay, with the same base, okay. Okay, compare this to the exponential form, that is e raised to r e raised to j theta. Okay. Take note, our e raised to something here is that our r. Okay, and this one, okay, also this one. Okay, so what do we mean by that now? Okay, the value of e raised to 0.6821 is our r. Okay, so our r is e raised to 0.6821. Okay, the value of that is 50.6821. Okay, so 1.9780. 1.0. Okay, 1.9870. 1.9780. 0.780. Okay, and take note now, if this is our j theta, so that is our theta here is 2.5367, and remember now, okay, the unit of this angle, the unit of this angle is in radian. Okay, so our theta is 2.5367, okay, in radian. So say for example, the required answer is in rectangular form. Okay, so you write this as, okay, our angle, our r is 1.780, and then our angle is what? 2.5367. Okay, radian. Okay, so say for example, the required form is in rectangular. Okay, so you should convert this now into rectangular form. So that is y equal to 1.9780. Okay, the cosine quantity cosine of 2.5367. Okay, so if the degree sign is not written, understood it is in radian, no? Plus j sine of 2.5367, right? So just type that in your calculator. Actually, no, uh that is equal to 1.780. Okay, quantity cosine 2.5367 plus I sine 2.537. So our record answer is negative 1.676270, and then plus 1.1248 plus j and 2.1248. Okay, so this is the equivalent um value na of the given um uh what do you call this, complex number with an exponent of a complex number, right? So that's it na. Okay, so if you have question, just comment down below guys na. Okay, and okay, so see you on our next video. Okay, thank you guys.